Welcome back to the lesson on limits, and this time we're looking at indeterminate form limits, which are basically limits that we cannot define or evaluate or determine by direct substitution. We like to organize the indeterminate form limits in different groups depending on the technique that is needed to use to evaluate each of them. We're going to start off with a factoring technique, which is most typically used in rational functions. Example B1, we have x squared minus 9 over x minus 3. That's a function whose limit we're trying to find as x approaches 3. So whenever I try to evaluate a limit, remember, you won't be given, one group of limits. You will be given a variety of them. So it is very helpful that you first use substitution to check and see if the limit is simple limit, A, or if it is not simple limit, then we understand what works and what doesn't work, and we can make a better decision at determining the approach that we have to use in order to evaluate it. So when I look at the limit as x approaches 3, x squared minus 9 over x minus 3, and I try to evaluate it by direct substitution, I notice that I will have 3 squared minus 9, this looks like a 0 already, and over 3 minus 3, so we end up with 0 over 0. So obviously, this is an indeterminate form limit, so we cannot evaluate it by direct substitution. So the next advantage to using or to trying to evaluate the limit by direct substitution here would be understanding the nature or the reason why this limit is indeterminate. As you can see in here, the value of the numerator at x equals 3 equals 0. And so is the value of the denominator at x equal to 3 equal to 0. So remember that based on the factor and remainder theorem, if a polynomial expression, and that is a polynomial expression in the numerator, so if a polynomial expression has a value of 0 at a certain x value, it means that x minus 3 will be a factor. So this gives us hope, thinking that if x minus 3 is a factor in the numerator, that can cancel the denominator, because the reason why we couldn't evaluate this is because denominator was 0. So this is how we make the decision on whether or not we have to use factoring or other techniques that we are learning very soon. So if you factor the numerator, then we'll have x plus 3x minus 3, that's difference of squares, divided by x minus 3. Now we see that we have the same factor, which simplifies to x plus 3. So it helps the function simplify to x plus 3. And now if you substitute x by 3, we have 3 plus 3, which means that the limit equals 6. So let's take a look at another example. Try to do this on your own, if possible. So I'm going to try to explain it again. So we have the limit as x approaches 2 of 8 minus x cubed over x squared minus 4. So a quick substitution. You don't really have to write everything down because, it is time consuming. But if I substitute x by 2, I see that 8 minus 2 cubed, that's going to be a 0. So this again tells me that x minus 2 has to be a factor in the numerator. And if I substituted x by 2 in the denominator, we have 2 squared minus 4, which is also 0, which tells me that x minus 2 must be a factor in the denominator. Now, with direct substitution, we obtain 0 over 0, which is an indeterminate form. So we have to convert it or simplify it so that we're able to determine this limit into a determinate form. So we're going to use the factoring technique again. And just to refresh your memory, here we have the difference of squares. I hope we remember the difference of squares formula, which is a squared minus b squared equals a plus b, a minus b. And the numerator is the difference of cubes. You can probably tell here that number 8 is a 2 to the power 3, and then we have minus x to the power 3. So it's a difference of cubes. And the formula for difference of cubes, to factor difference of cubes, we use a minus b here. And then the other factor, if you remember, looks very much like the perfect square trinomial, with only one difference, that we're going to have no coefficient in front of AB, so no number 2, which makes this non-factorable. So do not try to factor this part of the of the polynomial. So let's get started now. We have 2 to the power 3 minus x to the power 3. That means 2 minus x. And then the other factor would be 2 squared. I'm going to show the working here, but obviously this is not a must show step on the exam. You just or on any evaluation actually. So you simply write it in the most simplified form possible. These are simple calculations. And down here we'll have x minus 2. Let's be consistent with colors here since we chose to use them. So x minus 2, x plus 2. So now we were hoping that x minus 2 would be a factor to both numerator and denominator. We're done factoring here, and we see that x minus 2 is a factor in the numerator. We don't clearly see it in the numerator, but what we do see, which is similar to x minus 2 down here, is 2 minus x. You probably recognize this from, we've mentioned this in functions and in grade 11. So when you see that you have a binomial where the terms are exact opposites of each other, so x, negative x, 2, negative 2, it means that we can take out a factor of negative 1 from one of them. So I'll take out the factor of negative 1 from 2 minus x, and that will change 2 minus x into negative 1 times x minus 2. I will explain it on the side, just in case you need an extra explanation. So if we have 2 minus x, you list them from highest to lowest degree, which means that negative x comes first, and then you take negative 1 out, negative x becomes positive, and positive 2 becomes negative. And that's where we get the negative 1 times x minus 2 from. And the other factor is 4 plus 2x plus x squared. Now, in the denominator, we still have the same thing. So we have x minus 2 times x plus 2. And that would be the limit as x approaches 2. We have to keep on writing this. We have to write things in proper format. And now it's time, and this is the more exciting part of evaluating limits, simplify or chop. So the simplified limit would be x approaching 2, negative, and then we have 4 plus 2x, and then plus x squared, and I will try to keep this inside brackets. Actually, we have x plus 2 down in the denominator, so we're good. Now, remember that this was the indeterminate form, and we have converted this limit now into a format that we can, or into a form we can evaluate or determine it, which means we're ready to substitute number 2. So we have minus, and then we have 4 plus 2 times 2 plus 2 squared over 2 plus 2, and we simplify the numerator, which will be negative. We have a 4 and a 4 and another 4, so 3 of them will make a 12. And in the denominator, we have a 4, and that means that negative 12 over 4 is negative 3, and that would be the limit of this particular function. Let's continue with one more example where we can use the factoring technique. This time we have the limit as x approaches negative 1, x to the power 5 plus 1 over x plus 1. If I directly substitute x by negative 1, let's see what happens. So negative 1 to the power 5, that will give a negative 1 because the power is odd, plus 1, numerator is 0. So it seems that x plus 1, so basically x minus negative 1 or x plus 1 is a factor in the numerator. And obviously you substitute x by negative 1 in the denominator, and then we get negative 1 plus 1. So we get another 0 here, which means that we end up with a 0 over 0, which is undefined. So what that tells us is that we cannot evaluate or estimate by direct substitution. We have to use factoring. Now, since we know that x plus 1 will be a factor of the numerator, And I'm going to write the notes in here. You may want to write your own notes as well. Write them in a way that you understand. And remember, write funny notes, write silly notes, whatever helps you memorize or remember things better. So we're going to say that since we're going to say that x plus 1 is a factor of x to the power of 5 plus 1 because at x equals negative 1, the value of x plus 5, x to the power 5 plus 1 would be equal to 0 because it's negative 1 power 5 plus 1 equals 0. So knowing that we already got our first factor, we are going to divide x to the 5 plus 1 by x plus 1 so that we can figure out what the rest of, or what the other factor would be. For this, we're going to use synthetic division would be easier actually. And before I start with synthetic division, I will rewrite the polynomial x to the 5 plus 1 slightly differently. Remember that in synthetic division, we play with the coefficients of each term. And for this, we're going to need to have all the terms in place. So we need the term x to the 5, we need x to the 4, we need x to the 3, we need x squared, we need the term x, and we need the constant at the end. And whatever terms we don't have in here, we're going to give it a coefficient of 0. And lastly, we have the constant 1. So the coefficients that we are working with here are numbers 1, 0, 0, 0, 0. So 4 zeros there and a 1. So I will list the coefficients. So 0, 0, 0, 0, and then 1. I'm going to draw my fancy half rectangle here. That's not that fancy. Okay, now that's better. And we have negative 1, so we are talking about this negative 1 right here. And bring number 1 down. Multiply 1 by negative 1. So that will give negative 1. Write it down here. Add them. Negative 1. Again, same process. Whatever you get here, you multiply by negative 1. That's a positive 1. You add them. That's 1. Again, same thing. 1 times negative 1. That's negative 1. We add them. That would be negative 1. Again, multiply negative 1 times negative 1. It's a positive 1. Add them. 0 plus 1 is 1. And lastly, we multiply number 1 here by negative 1 again. And we have negative 1. When you add them, we get a 0. And that would be the remainder as promised, which tells us one more time that x plus 1 is indeed a factor of x to the 5 plus 1. So the other factor then will have to be, remember that power of 5 divided by power of 1 would give power 4. So our first term here will be x to the 4. The next one, x to the 3. And then we have x squared and then x. And then the last one will be the constant term. So if we were to write that function now inside the limit in factored form, long line here. And then we'll have x plus 1 times x to the 4 minus x power 3 plus x power 2 minus x plus 1, close brackets, over x plus 1. And now the moment we've been waiting for, chop, chop, and here goes the limit as x approaches negative 1 of x to the 4 minus x to the 3 plus x squared minus x plus 1. Now here I'm going to tell you something else that is very important and easy to forget. Now whenever you have the limit of an expression that has multiple terms, it is very important that we keep this inside the brackets, because if we don't, then we can look at this expression as if we are taking the limit at x to the power 4 and then we are subtracting the rest of the terms. So this is one of the properties of limits that we are going to talk about in the upcoming lessons. And now it's time for us to substitute because we have no more obstacles. So negative 1 to the power of 4 minus negative 1 power 3. I'm going slowly so that I won't lose anyone in the process. Obviously, you can speed up the video if you wish. Okay, And here we go. Negative 1 power 4 is positive 1, and that's because even power. And then we have negative, so negative 1 power 3 is negative 1. And then plus, negative 1 squared is positive 1. Now these two minuses together will make a plus and then plus 1. So these two negatives will make a positive. So we have 1 plus 1 plus 1 plus 1 plus 1. We have 5 of them, which means that the limit equals 5. So I will continue with the next part of the lesson in the next video. And thank you for learning with me, and I hope you find this useful. Bye for now.